Hello, hello, beautiful people. I am so happy to have you join us today. I'm going to bring in our guests already, so then we can automatically get this ball rolling. Hello, everyone. My name is Teron Foxfirst, if you didn't know, developer advocate at Meroxa. And here I have with me a dear friend, investor, author, engineer, and super all-around great guy, Chris Riccomini. Hi, Chris. How you doing?
Hi, thanks for having me.
Would you love to give the people a 5-minute elevator pitch of yourself?
Sure. So, uh, I think, first and foremost, an engineer and manager. I've been in the industry, software industry, that is, for about 15 years or so. Most recently, I've been at a company called WePay, which was acquired by JP Morgan and Chase a few years back. And at that company, I spent most of my time in the data infrastructure and data engineering space. So kind of a somewhat unique perspective in that JP Morgan Chase is one of the largest, if not the largest bank in North America, heavily regulated, a lot of compliance, and fintech, as well. So that's sort of, I think, the most recent experience that I have and the perspective that I bring. Prior to that, about 6.5 years at LinkedIn, where I spent, again, a lot of time in the data space. I joined as a data scientist for about a year and a half or so, kind of before that was a word. And then I spent the better part of 5 or 6 years doing infrastructure-related work, initially service mesh and service infrastructure, and then streaming. I also did a lot of work on Hadoop and big data processing.
Mm-hmm.
And then going back even farther, again, I was back in fintech doing PayPal data science and fraud detection stuff. And I've written a book. That's the other thing I think you were publicizing on Twitter recently with a co-author of mine, Dmitry Ryaboi, who's works at a biotech company called Zymergen. And the book's kind of meant to introduce software engineers to the workforce. You know, we find that a lot of engineers coming in from either college or from boot camp just have, through no fault of their own, gaps that aren't really taught in traditional curriculum. And, as managers, I think you start to pick up on this pattern with people that you hire. And so it's like, well, I wish we had a manual to help bootstrap them and get them up to speed. And so that's what the book is. It's called The Missing Readme, and it came out in August. So that's me in a nutshell.
I love it. I just started reading the book. It's great. I'm going to type up a whole blog post about it. I got you. However, I love your experience because here's my first question for you. Do you consider yourself a data engineer or a software engineer?
I think that's a tough one, man.
I'm sorry. I threw that one on you.
I think I consider myself a software engineer. I kind of fell into the data engineering space and into the software engineering space just through sort of pragmatism and like trying to solve the problems that were at hand. And so, as I mentioned, I started as a data scientist, and I kind of discovered, like I can build a model, but a lot of the work is actually in productizing the model and getting the data where it needs to be. And so I kind of switched over to software engineering and doing more development, and that led me down the path of infrastructure stuff. So, I think my online persona, for lack of a better term, is a lot of data-ish stuff, but I like to think of myself as more of a well-rounded software engineer.
And I guess that's what kind of sparked my question, because like following you, I learned a lot of data stuff, but I think there's this really interesting balance between the software engineering world and the data engineering world that's happening right now. And I wouldn't say they're conflicting. I would more so say they're dancing, right? Like it's at least that's what it feels like to me. So I think for this next question, you would be the perfect person to give this perspective. So, me as a software engineer, and I'm seeing everything in the news about how data is taking over the world, and obviously, data is becoming more and more part of the software engineering world. What are those kind of key main things that we should bring, that the ideas that are in the data world that a software engineer should start to learn about and embrace, I shall say?
Yeah, good question. I think I have a sort of a two different answers. One of
Ooh.
them is from the perspective of, I'm an application engineer. I'm building a product, and I'm interacting with an increasingly diverse set of, for lack of a better term, data infrastructure, databases,
Mhm.
streaming systems, workflow orchestration. There's like this whole tool set of stuff there. And so my first answer is really coming at it from that perspective. And how do I build an application that is reliable and provides the user experience I want? And I sort of don't, the way I phrase it is I don't saw my own arm off with these power tools. And so I think for that perspective or that question, it really comes down to understanding the systems that you're using and sort of the nuances, especially as you branch off from traditional relational databases into, eventually consistent databases or, multi-region, multi-zonal type systems, new
Mhm.
SQL. And so, the sort of pithy one sentence response is Martin Kleppman has a fantastic book, Designing Data Intensive Applications. And that is the Bible for answering this question. Like you basically should read that book
Yeah.
and internalize it. And that will give you a ton of great information about how to, build applications on top of these systems. A slightly more in depth would be, understanding the partitioning scheme, the consistency guarantees, stuff like that, replication schemes, the latency characteristics of the databases and tools that you're using are critical for building stable applications. The second sort of direction that I come at this from is kind of like, I'm an application engineer, I'm a product development engineer. How do I partner with data engineering to make sure that the stuff I'm doing is consumable by them, and that we're working together to build under what is data mesh terminology, like data products and stuff of that ilk that the organization and external customers can all use. I think for that, probably the most important thing, and selfishly from my perspective as a data engineer, what I want from my application engineers is for them to think a lot about and understand schema management and backwards and forwards compatibility. So if you do one thing to invest, if you invest time in one thing and learn more about one thing to make life easier, not only for the data engineers you work with, but also just for the people using your data, it is understanding the importance of the schema changes you're doing and how that affects downstream consumers. And even popping up a level, understanding that there are downstream consumers of your data. Oftentimes, we are promised as application engineers that our databases are, fully encapsulated and sort of an implementation detail of our microservice or our monolith or whatever. But in reality, we are, of course, reading that data for, historically, reporting and chart generation, business ops kind of stuff, but more recently also to create data products that our customers end up using. And so you really do need to start to understand what effect you're having on those downstream consumers when you mutate schemas. Beyond that, there's a whole other slew of stuff you can do to build good relationship with data engineers, understanding the tooling that's available and working with them, kind of the way that you would work with an SRE or ops team to keep them apprised of what you're doing and so on. So.
Is I did the good mute myself. Oh, I love live shows. I was gonna say, I think from a software engineering perspective, you can see, like you said, the same thing happening in DevOps, right? Because
Mhm.
Docker and Kubernetes, I'm learning more about those tools, and now that we got DBT and Snowflake, right? Now just software engineers learn more about that. So how can we be better stewards to the data engineers and vice versa?
Mhm.
Makes total sense. And I think everything that you kind of listed there, the book Data Intensive Apps, I highly recommend. It kind of fits perfectly with this conversation, right? Because um, I'm going to share my screen and share with you all some fun illustrations I tried to come up with to describe some of the problems that we may have today, because visuals are needed and they're super important. So today's topic is all about database snapshots, right? And we're going to kick off with database snapshots and what they are. But really, I want to start off with kind of this idea here. If my technical difficulties, there we go. So I really want to start here. I feel like this is the entry point where most software engineers really care about where their data is. It's when it's you there at 3 a.m. and your database just filled up, and you have to now ask the next question: what do you do? And that opens you up into the world of like how your database is stored on disk. How do you now get into sharding and partitioning of databases? And then how do you then get data into a warehouse where everyone else, so it like explodes all these other questions. So that's
Yeah.
kind of where I would start. I wanted to start with you now is, as a software engineer, this is one place where I might come across snapshots. Where
Mhm.
have you else were you seen that may have been, snapshot things that software engineers may do or come across?
Yeah, yeah. So I think two other use cases I think that come to mind that aren't immediately obvious as snapshots, at least the way that a data engineer might think about them for loading a data warehouse or something, are just backup, like for recovery. So I have a database. I'm going to set up a nightly job that's snapshotting tables or what have you, so that in the case of a disaster, I can recover. Um, the second one is, and you've got a similar visual there, but sort of read or write query load, where you decide that you want to go from one database instance to many database instances, and they should all have essentially the same data. You just want to be able to scale out your reads and writes. So, I think broadly, I would sort of classify those into durability and scalability use cases on the sort of online application development side of things. So I think those are probably the first couple instances where you come across it and don't really think much of it as a snapshot, especially in the case of recovery. You're usually thinking about it's like a one-time thing that kicks off every day or every month or what have you. I think if you go a little bit farther, the next level is like, you have your monolith and you're successful and you want to break that up and start building out microservices as you grow for various reasons. So you have this monolithic database and you decide, well, now we have microservices and we need to have, one DB instance per microservice. And so you start trying to pull data from the monolith into the microservice databases, usually at the table level, sometimes at the database level as well. And so you have to think through how you get the data from the monolithic DB to the microservice DB in a way that doesn't corrupt it, that you don't lose any records, that conforms to the new DB type. If it's not the same type of DB, it may be going from a MySQL instance to a Postgres, or MySQL to a Mariah DB, or what have you, Mongo. So that starts to open up a whole new can of worms around mapping data types and transformation and data quality checks and stuff like that. So I think those are sort of the first few examples I think that you would come across snapshotting as an application engineer developing.
Do you think the database snapshots are like a problem, like a scaling problem or a problem that you hit at scale?
Um, I think you definitely do hit them at scale, but I wouldn't say that's the only reason. Going back to the durability example and
Yes.
disaster recovery and stuff, I think if you're dealing, you're in the healthcare space, or you're dealing in fintech, to use my example, or just in general, if your data is very valuable, you may not be worried so much about scale, but you don't want to lose the data because it's really important, right? So I think there's definitely a durability aspect to it as well. I think I'm definitely more biased with the LinkedIn background towards scale, and but I think durability plays a role as well.
That's awesome. So, okay, we kind of defined snapshots. We got some real world examples. Let's talk about implementation. So, there's one big implementation of this today that we all know and love, and kind of hinted at it at the title of this video. Select star. Because what else does the developer turn to on how do I get everything out of this database or out of this table? That's the easiest, queryable way. But I want to talk about this. Why is this the problem, and when is it not a problem?
Yep. Yeah. So I think as you've said, the most common way that you snapshot data is you execute a select star, and you funnel the results to a local file, a GCS bucket, an S3 bucket, or whatever, and you kind of move on with your life. I think that works quite well, and in fact is not an unreasonable approach. Even at my previous job at WePay, we would do select star snapshots when we could get away with it, because it's the easiest to reason about in a lot of ways. Unfortunately, there are some downsides to it. Executing sort of an unbounded select star on your data, especially if the data is quite large, can have a performance impact on the database. When we would do this with MySQL, for example, it would grab locks, and some of these more modern tools that do snapshotting are a little more savvy about what kind of locks they grab and when. But in order to make sure that your data is consistent when you're snapshotting, you usually have to grab locks. And then, of course, that can impact read and write load from other processes that are interacting with the database. So you definitely have to be cognizant of performance when you're doing snapshots. I think the second thing is usually you need to know when you snapshot, you don't usually do a select star up to an unbounded point in time. You usually bound it to 5 minutes ago or 10 minutes ago, and that's to allow any transactions that are being held to kind of finish out and to give you a full view of the data. And in that case, you end up having to impose some schema requirements on the tables, like maybe you need a create time or a modified time or an incremental primary key ID or something. And sometimes it's easy to impose those requirements, other times not. I think I've interacted, I've worked at some companies where the ORM that they use is fairly rigid, unmaintained, dead on the internet, and yet it is the backbone of the application that's being run. And in those cases, you kind of have to be a little more tricky and deal with the schema as it comes, because it's just really difficult to change things. So schema is definitely something to think about as you're doing select star. And yeah, I think I'll leave it there. I think those are kind of the two primary ones: performance and schema.
And I hate to do this to you live, but I'm going to throw a question in there that I'm super interested in. I agree with you on like the schema thing, because as I've been thinking about, like, it all comes down to really a consistent intermediate. Are you excited about any schema tools or things in the schema space that solve some of these problems? Or are you still looking for that one that scratches the itch?
I'm still looking for the one that scratches the itch, I would say. I think the way I think about the schema stuff and really transformation in general is you can do it in the DB. And so a classic example of this is something called the outbox pattern, which Gunnar Morling has some really good blog posts on. He's the one of the maintainers of the Divisium project, and that's a situation where you have your table in your database, and you're doing some stuff in the DB, and you end up with this outbox, which that's what you use to move data out of the database. So the first point you can do it is sort of in the source database. The second point is in flight. And so that might be stream processing, or it might be some kind of transformation happening on an Airflow instance, for example. And then the third place is you can do it downstream once you've loaded it into the downstream sync, whatever that's going to be. So that would be more of an ELT kind of a pattern as opposed to an ETL. I guess the first way would be, I've never heard it described this way, but a transform extract load. Choose where you move the T around. But
this is how buzzwords are made.
Oh man, we just nailed it. ETL, right? So I think there's tons of transformation tools out there. But the thing I'm looking for that I haven't really found yet is one that will help either data engineers and or application engineers build these quote unquote data products, which are the kinds of things that a data mesh architecture wants, where you have, strongly versioned, maybe some kind of semantic versioning on the data you're exposing. You have the ability to do transformation so you can decouple your internal schema from what's getting exposed externally. I think we'll see those tools in the coming years, but right now I think it's still pretty early days, and so a lot of what you're stuck with is like, well, the table looks this way in the database, and we're gonna have to make do with what we have.
You make with the best what you got. The most effective, the most efficient tool is the one that's right there. I have a question from the audience. So when you snapshot, like you were talking about, and I think this is where this question is coming from, you're talking about how, in the fintech or health space, the need for snapshot comes from backup and redundancy. Are there any additional security measures that you need to take in place there to keep those snapshots secure?
I think it's gonna depend a lot on what is in the data, how crazy you want to get with it. So there's everything from like offline cold storage, where you can literally put your snapshots in a place where they're not accessible on the internet. There's the next level up from that is probably nearline storage, or not nearline, but online cold storage, which I guess is something like Glacier or some of the tiered S3 storage techniques that they have. So there's sort of an isolation aspect to it, independent of like crypto and access and stuff. Just like how far removed do you want it to be from access on the internet? I think when it comes to cryptography and stuff, yeah, you can do encryption at rest, you can do encryption in flight, all that kind of stuff. And definitely, I think where I've seen that most often implemented is like because you have to, compliance or security reasons, not usually voluntarily, but it does happen. And then I think the third thing is really around access control. So who's authorized to access it, and who has the keys to the castle and stuff. And that kind of goes hand in hand with this isolation stuff I was talking about, who has access to the S3 buckets and stuff. And it's going to be different for each individual use case. I think when you're dealing with things like PCI or health and PII type stuff, then you want to be really careful and probably want to isolate it, keep access really low, rotate encryption keys, all the standard best practices and stuff.
Yeah, Chris, I love our conversations because we were talking about data quality checks. And that fits so well in here because, okay, I've now snapshotted it and I made sure it's secure on the other end. Well, here's the next question. How do I then validate that the data that was here is now over there?
Yeah. So I guess if we're kind of popping up the stack, so to speak, in the conversation, and we're talking now about snapshotting data from a database for the purpose of loading it into a downstream system. It might be the same database, it might be a different one. I think I've implemented two different schemes for data quality checking, and I've seen two other ones that I think are really interesting. So the two that we implemented when I was at WePay were fairly rudimentary, but actually quite effective in doing data quality checking. The first was just row counts. So counting how many records are in your source database, and then counting how many records are in your destination database. And if those two numbers align, yay, right? It's a sign that things are probably okay. Now, of course, there's latency in the pipeline. And so a write that occurs at your source database may not end up immediately in your destination database. So you have to be a little more clever about windowing and sort of looking at data over a certain window. Row counts definitely give you a good hint. I think the second level of data quality checking that we implemented that was much more rigorous was we actually did row by row, column by column checks. So we would take a slice, usually an 84th, and I won't get into why it was 1/84th, but it was an 84th of the source table. We would select that data out, and then we get that same slice from the destination table, and we go row by row, column by column, and validate the two match. And that would give us a much deeper confidence that the data was identical. It's a bit brute force, and it was not a super scalable thing, but it worked in our use case, and so we went with it. A version of that that's sort of somewhere in between the row count, which I would say is easy but not super accurate, and the exact checking, which is accurate but not super easy, is something like anomaly detection or using ML to do automated data quality checks to really just look for oddities in your data. And so if you snapshot from your source and your destination gets loaded, the ML might be able to pick up on weird patterns in the data that might not have been in the source. Usually the ML systems don't leverage the source data. They just look for weird stuff in the destination data. So that system has applications beyond snapshotting. I think the final thing that I've seen talked about lately on the internet that I think is really cool, and actually we had a ticket open when I was at WePay to kind of look into this, and it was sitting there for several years. We never got to it, but the idea is rather than doing full row by row, column by column checks, you checksum your source data. There's a really good blog post. I think it's called Napkin Problems is the name of the blog. And the post talks about implementing checksumming on your snapshot, your source data. And then when you load it, you do a checksum on the destination data. And if the two checksums match, you know everything is identical. And then you can be slightly more sophisticated than that. And the post alludes to this as well, but doesn't go in depth on it. And you can build something called a Merkle tree, which will let you not only validate if the two data sets are identical, but also if they're not identical, it'll let you kind of traverse the range of data and find where the gaps are. This is a data structure that's kind of widely used in distributed systems. Cassandra uses it heavily to detect inconsistency between nodes, and it's something that is really effective. And so I think a more advanced version where you need high quality, high fidelity guarantee that your snapshot looks okay, but maybe are more performance conscious than we were with our, row by row, column by column checks. You would do something like a Merkle tree or a checksum based approach to do data quality.
Yeah, Merkle trees are like the one thing that still come up from my CS background. I mean, obviously a lot of stuff comes up, but that's probably the one that comes up the most. It's probably skewed because we're data people, but data quality. I feel like that we can go on that probably in a whole show within itself.
Yeah.
But as we led to this, we kind of started at the select star, right? And you mentioned that select star works for a lot of cases. There are some cases where, hey, you're now select starring on a database and that thing has performance, or it's now locking it, and meaning you can't do something else with the database. So what are some of the solutions that are alternatives to select star? And you touched on these in the data quality and the security conversation, but I would love to isolate that. Okay, well, if I am now at pushing the limits of select star, what do I do?
Yeah. I think there's there are two that I see employed. So one of them is, I think, less common and really more, it depends on how the database is implemented, but select star you can kind of think of as a logical level snapshot where you're executing a query against the database through the standard API and you're getting your results back and you're spooling them out, wherever. I think a more physical based snapshot would be one in which, you're copying actual files from disk to another location. And in some cases, databases will tolerate that, and you can actually just rsync or CP or SCP or whatever it is, the files where they need to go. I see that once in a while, but it's generally less common. It was something we did with one of our internal distributed systems at WePay that worked pretty well, but that internal system was tolerant to just copying blocks around and stuff. I think the stuff that's a little more cutting edge and looks really promising to me is something called incremental snapshotting, which is something that I believe came out of Netflix, or at least that's where I first came across it. It's a paper that they published a couple years ago where they kind of document a technique for executing a select star on sort of a time-bounded window and doing it on just a portion of the data. So you would, go from, rows 0 to 1000 and then rows 1001 to 2000, and you would chunk along in these incremental loads. And that's really valuable when your data gets big, because it means you can pause, you can restart, you can minimize the impact on query load because the select star you're only pulling 1,000 records or whatever. So it's not terabytes of data that you're trying to pull down from the DB. I don't know what they call it, the algorithm or pattern incremental snapshot is actually fairly flexible. It's not like it's implementation specific to something like just MySQL. So there's a pretty solid Debezium blog post. And for those that aren't aware, Debezium is a change data capture system that, among other things, supports snapshotting of databases to load data into downstream systems. Usually Kafka is the one that people use it with. In any case, Debezium has a really great blog post where they kind of describe incremental snapshotting, how it works, and their implementation, which I believe is generic and works with like MySQL, Postgres, and maybe a few other ones that they support. So that's really promising to me. I can't say that I've used it personally yet, but it was definitely something that we were evaluating at WePay. So I think those are kind of the other two snapshotting approaches that I see come up somewhat frequently. Yeah.
It really seems like there are trade-offs everywhere.
Yeah.
So I know I asked you this before, but so there are, like, if I need to get started with snapshots, there are things I need to know about the underlying system that's storing the data.
Mm-hmm.
Because then me as a software engineer, then I know how to attack this particular snapshot from this particular system. So if now I'm snapshotting things, what could you give me like what are some questions I can ask myself to kind of, make through these decision trees of the best tools and the best routes that you can pick to snapshot things?
Yeah, that's a good question. What questions to ask? So I think the most important thing to understand when you decide that you need to do a snapshot is really the size of the data and the performance characteristics of the database that you're going to be interacting with. So, if you're snapshotting 100 megs of data, 50 megs of data, that's one thing. If you're snapshotting 100 gigs, a terabyte, 100 terabytes of data, that's another thing, right? So understanding the size of the data is important. When it comes to performance characteristics, it's really just what is the impact of this query going to be on the database? And along with that, who is going to get impacted? If you're snapshotting, from some replica that nobody else is reading from, you can abuse that thing quite a bit. And so it may be perfectly fine to keep a TCP connection open to it or 100 TCP connections open to it for hours on end. If, however, the thing you're snapshotting from is a production system that's handling customer query load, you need to be much more thoughtful about how you pull the data off. So I think performance and impact on other customers is something to consider. I think another question, and to be honest, these are fairly generic answers because a lot of this is going to depend on which database and what kind of system and what it's on. But I think these are the kinds of questions to dig into. So another thing to look at would be, do you need to transform the data before or after you're snapshotting? Getting back to that ELT, ETL discussion before, you almost always have to do some level of data munging to get the data from the source into the destination. Maybe the upstream has a date time column, but the downstream only has integer. And so you've got to do some UTC conversion or what have you. Understanding the data munging that has to happen is important. And I think lastly, the consistency guarantees are something to consider. So, and what I mean by that is, when you select data from a upstream database, you're going to see usually a snapshot of that data at a point in time, and the guarantees around what snapshot you're. And I'm overloading the term. You're going to see a view of that data at a specific point in time, and the database will determine based on its acidity guarantees and serializable guarantees, like what rows you're going to see when you run that query. Understanding that is important because usually what's going to happen when you snapshot is it's not a one-time thing. You don't just snapshot and then you're done. Usually after you've done the initial snapshot, you're trying to then from then on incrementally load. And so you need to understand very clearly where the boundary is between when the snapshot is done, what was the last row you got, so that you can flip over to an incremental load starting from the next row. And so there are a lot of nuances, even in traditional relational databases, around consistency guarantees and transactionality and what's happening with the other writes while you're running your query. So you got to understand that. And I think as you expand out from traditional RDBMS into NoSQL and NewSQL stuff, it gets even crazier. Eventually consistent systems and spanner clocks and all that kind of stuff. So I think it's important to investigate in that area as well. Lastly, I would say spend some time investigating tooling. There's a whole bunch of, I discovered, when we started running MySQL in production at WePay, LinkedIn was heavily Oracle at the time I was there. So I was not too familiar with MySQL, but over the past 6.5 years, there's like a whole suite and ecosystem of tools available to you. And, database administrators often know all these little secrets and tricks, and, MySQL dump is available and, what you can and can't do and stuff. And so spending the time to investigate the operational and administrative tools for the database is worth doing, because oftentimes you'll find that they have little tricks or abilities or knobs to turn that will make snapshotting easier. So that's some guidance that I would suggest.
That's a great playbook. That's like a nice 1, 2, 3. So thank you, Chris.
Sure. Yeah.
We're going to have to chat again because all you did was give me more questions. However, I would love to reintroduce you. So everyone, thank you for watching. We had today with us Chris Riccomini, engineer, investor, author, friend of mine. And I would love for you all to go check out his book, The Missing README. Like I mentioned, I started reading it. It's super good. It's well needed. I think it's a good level setting, even for engineers, kind of like, oh yeah, I did learn about this, and it's good. It's new language. It's refreshing to read this again. So please go check it out. Chris, do you have any final words for the people?
No, I guess I just appreciate you taking the time to chat with me. This was a lot of fun. I was telling you before, and this is like the most sophisticated production quality discussion I've ever had. So props on that. I really appreciate it. Thanks for having me. Happy Thursday. Yeah.
Awesome. All right, Chris. Thank you so much. To you all, thank you for watching. This is episode 4 of Real Time with Meroxa. In January, we have a very special episode for you planned. So I can't wait to see you there. And until next time, have a beautiful day, you all.